Okay, so today's class is sequence and series. Okay, which are starting with the new chapter here. Okay, so what is sequence and series? Okay, so I think you have might have known this word from the Form 4 and Form 5. In those times, you only learn about two things, what we call the arithmetic progression, and also if you go a bit lower, you learn about geometry progressions. Okay, those are two things you mainly learned in Form 4, Form 5. So when you ask what you learned back in Form 6, okay, you actually touch up on what you learned back in those times. Okay, I learned about the sum, okay, sum to n term and all that. I also learned just a bit more. Okay, when you go to the sum of infinity and whatnot, and also how to use the sigma symbol. Okay, this is what we call the capital sigma. Okay, is to denote a sum from a certain amount. Okay, so we just use this symbol. It's okay, don't worry about it. We will go through all of this. Okay, and these are familiar. Okay, these are some of the more important formulae of this semester. Wait, give me a moment. Okay, sorry. Okay, don't mind that. Okay. Then you also have at the end of this chapter, uh, the last subchapter we have what we call binomial expansions. Okay. So binomial expansions, it's using Pascal's triangle. Okay. I'll explain later more about what is Pascal's triangle. Basically, you just have to know that it explains that it makes when you have a quadratic function when you square it, there's a certain formula for it, right? So imagine if it's a polygonal formula. Okay, power isn't just two. The power could be with three, four, five, and so on, and it can has a formula to how to explain it in a very neat and very nice way. Okay, so we also go through. Okay, so how about let's application. Now I'll go through some questions with let's see. Okay, let's try to do let's try to do the first question here. Okay, write the four terms of sequence. Okay, so a equals to a1 equals to -4. Okay, so what could be the four terms of this sequence? How would this continue? Okay, they have a formula here. They already give the formula an equals to an minus 1 plus 5. So, would you like to answer this first? Would you like to give it a try? Or I can just proceed. You know what? I'll just proceed. Okay, so always you always start with the A1. Okay, so A1 is given. Okay, we'll always start with A1. So A1 is okay, with 4. Okay, then what do you do after A1? What do you do with after A1? You go for A2, right? Okay, so A2. Okay, then you can start using this thing. Okay, start using the sequence they have given. So A2, so for AN, okay, using AN equals to AN minus 1 plus 5, you just use that. Okay, so what's AN minus 5? So that's 2 minus 1. Okay, so that 2 minus 1 become what? 2 minus 1 is A1. Okay, so that's -4 plus 5. So that'll give you 1. Okay, and A3 will give you 6. Okay, A4 will give you 11. Okay,
Okay.
right. So that's That's just the simplest question. Wow, this chapter. It's never this easy, but let's do it. Okay, let's start with the second one. Okay. Okay. Second question.
No.
Okay, how about this one? Okay. Write the first five terms of sequence with the recursive formula. Okay, what is the formula? Okay. So split n equals to negative 1 to the power of n times 5 n minus 1 with a1 equals to 3. Okay, it looks scary, but actually it's not anything wrong. Just, okay, let's just always take up what's going on here. Okay, a1 equals to 3. That's the first thing you have to remember. Okay, that's the data they given, and also the formula is that a1 equals to the 1 n equals to 5 a n minus 1. Okay, for this one, actually what they're trying to do here is for all odd values of n, okay, for all n equals odd, okay, the value will be negative. For values of n that is even, value will be positive. That's all. That's what this denotation here it means. Okay. This the thing in the back here is 5a minus 1. Other one is normal. Okay. What's not normal is this in front here. This and negative 1 to the power of n. This thing exists here, or just to change the sign of the value. Okay. So you might have like a normal progression since the sign of it is changing. So you have a different value each time. So okay, how about let's try inputting 2 into the equation. Let's try inputting 2. So input 2, what happens to it? I don't know. Yeah, I need to. Yeah. Okay, so I'll get a2 equals to negative 1, 5, 2, 5. Okay, 2 minus 1 is basic just 3. So that's 3. Okay, negative number to the square is also going to be positive number, so it's just 15. Okay. So okay, let's just skip through here. A3, A4, A5. Okay, so answers are 15, negative 75. If I'm not mistaken. This will be 300. I think 375. Yeah, 375. Oh wait, should be negative 375. Sorry. And then finally, last one will be 18785. Okay, so these are the five terms. You can leave it like that, or you can actually this all you can just write it like this, okay, and put them all here, and so close enough. No problem. I think this is sometimes troublesome getting it like this. So I just like to leave it like that. But make sure you always write down your A1, A2, A3, A4, A. Clearly, you mentioned these are the types. Okay, that's just one thing you have to do. Okay, I think we can go for maybe a bit harder question. Okay, let's try something a bit harder. Oh yeah, question 3. There's a problem. Question 3 is not fully defined. Okay, don't worry about that. Okay, so calculate the limit n squared plus 3n and 5 plus n. So how do you go about this? Okay, so limit to infinity when it comes to these things. You learn later in semester 2, but uh, I can just show you here. One thing when it comes to limit here, it's not so easy as in okay, I see it's from n bar n from infinity. We can just say infinity or infinity equal to zero. Okay, cannot say that. Cannot say that. Or infinity equals to one. We cannot say these things. Okay. So we have to actually mathematically show how we get these values. Okay, so how do we show that?
Can I send my working?
Oh, okay. Have you attempted all the questions already?
Not all, few from each.
Few from each. Okay, which questions have you
Each
attempted?
means 2.1, 2.2, 2.3.
Yeah, which questions?
4.
Oh, you attempted four.
Mm.
Okay, sure. Why not? Go ahead. Yeah, I'll just start. Okay.
Sharvina not coming?
No, I don't think so.
Mm.
Divide by n divide by n 1/3 equals to 1. Yep. Okay. This is good. Good. Good job. Okay. Basically just divide by n. Okay. You just have to get rid of the highest power. That's the trick. Okay, good job. Okay, then. Okay, have you done any other questions?
Yes.
Okay, then why not you send all of them now so we can go through those first?
Mm. Okay. Huh?
Yeah, let's go through the question together. Okay.
Okay.
Okay. So again, this lim into infinity. Okay. So this one it says that n squared plus square root of 3 over n plus n. Okay. Then over pi plus n to the power of 4. Okay, if you wanted to do it the fastest way possible, actually you can just divide everything by the power of 4. Divide by everything by the n power 4. Divide both sides by n4 and also n4. Okay, if you want it short. Okay, then when you do that, wait, let me see if what we did here. Okay, n4, 3n, n squared, n squared, n power 8. You square everything, is that right? Yeah, you cannot square this whole thing. I think the best option here is actually you just divide everything by n power of. Okay, so the problem you had was this thing, right? This three uh square root 2 over square root n. Okay, this thing actually you can actually remember if something is square root a over b is also the same as square root a over square root b. So when you divide everything by n over 4, you can just get this n over 4 over n over 4. Oh, it's n power 2. Okay, it's n power 2. Is 2. Okay, and minus square root 3 over n. Okay, you can just write it as 1 over 2. Okay, remember that square root is okay. It will also be written as half. Okay, n power 4 is first and plus 1 over n over 3. Then continue power also same. So this will be a pi over
N to the power of 1 over 2.
Yes.
Mm,
Power of 1 over 2. Any problem there?
why we separate it?
You can write it together also, but I'm just dividing everything by n power 4. Doesn't it's extra step if you want to put it together, so then you have to write it back everything again. What? So I'm just leaving it like this here because it's I can just easily read it. Okay, okay, so
Mhm.
actually I can just put n over n squared spread over 3. How much is it? 5 over 2. Wait, so that's 9 over 2. 9 over 3. So if I want to solve this, right, just me writing back the same thing again, I think this is been a bit unnecessary. So I don't think I'm gonna do that. Just gonna just those limit to infinity. So as n approaches infinity, okay, so we know this is if you approach infinity, you guys just hit 0. Then here same thing, constant. Is it? I think what's the constant on top? If bottom approaches infinity, then you still get 0, 0. If everything up here already 0, then you already know the answer. Lah. Here also same 0, then plus 1. So your final answer will be 1. Sorry, your final answer will be 0. Okay.
Mm,
Okay. This one I'm not sure why you did it like this, but it's okay. Trial and error. Okay, let's go for question 6. Have you already attempted question
It's
6
like
already?
this because I'm less smart.
Yeah, no, no such thing as that. Just haven't tackled problem. That's all. Okay, let's try question 6, and we can go for the harder questions. Huh?
Okay, this question I didn't try, so I will tell. I will do now. Or
Yeah, sure.
I will tell you what to write.
What to you will tell me what to write.
Huh.
So you want me to write whatever you say. Is that it? Is
No,
that
I
it?
will tell you. I will tell you what I understand, how to do this question, and then you can correct me.
Okay. All right. Sure. I'll just proceed normally by how we usually solve these type of questions. This, in any of these questions, whenever there's an n to infinity, there's the same thing as what we did just now. It's always you find the one with the highest power. Sometimes the highest power for what? The denominator. Okay, it's always highest power for the denominator. Okay, the denominator can sometimes you can even have a higher power for the denominator. So this is one example of this equation. Okay, so when you divide everything by n squared, you'll get a 3 3n half, right? That's 1 over 2 over n squared plus 7. Okay, you get n to the power of 4 here. Okay, and this is just n. Then after that, you get 2 plus 2008
Okay.
over n squared. Okay, so this thing here, okay, this will give you 0. Okay, I just go to infinity. This will give me 0, 0, and then here will give me infinity. Okay, and then it's over 2 plus 0. Okay, this you can actually you have to mention as a positive infinity. Okay, this is an important bit.
If it's minus n, then negative
Negative,
infinity.
yes.
Okay.
Okay, so this is the positive infinity over 2. which does nothing because infinity divided by 2 is still infinity, so your answer is, your final answer will be positive infinity. Okay, so this is a one such example where, if you notice before this, the either the numerator and denominator had the highest coefficient for power, okay, or if not, the denominator will have a low one, okay. But you always follow what the denominator. We don't mind what's up here. We only care about what's down there. The same thing here also. We only care about what's down here. But here, yeah, sometimes you can also have something that's higher and you just leave it there. You don't have to go into n over 3. If you do go into n over 3, for example, then what will end up here is, okay, let's say you divide this by n3. You will get here 0 and plus here 0. So in that case, then you will get your answer will be something like 1 over 0, which is undefined. And so just be undefined. Okay, then it will be just be wrong lah if you divided everything by n power 3. Okay, so try not to do that. Okay, so that's a bit of the easier questions. Let's go for something a bit harder. Maybe we can go for question number, let me see. Okay, 13. 13 seems like a bit of a, so it's keeping a few questions, don't worry. Okay, so let's go to question 13. So how do we approach question 13? Okay, let's read the question first. If 3k plus 4, 14, and k squared minus 5k are consecutive terms in an arithmetic sequence. Okay, so we don't know where it starts. Okay, this could be the first term, or it could be the second term, or it could be anywhere in the region. So how do we first solve this question? Okay, how we solve this is through the formula. Okay, so how do you do here? So through the formula, you have to remember this thing. L equals to A plus n minus 1 t. Okay, this thing. So in between the one term to second term is what we call the d. So how do we find d in this situation? Okay, you can find d very easily. Just d equals to 14 minus 3k plus 4. Okay, or you can say also equals to what? 5 k squared minus 5 minus 14, right? These are both the same thing. The minus, okay, let's call this A, B, and C. So since all of them are arithmetic, so C minus B has to be equal to B minus A. It has to be. So that's what I did here also. C minus B has to equal to B minus A. Okay. I'm just going to simplify this. I'm not going to open everything. I hope you can just follow through with that. Okay, so I'll end up with k squared minus 2k minus 24, okay, equal to 0. I will get this. Then I think from here you can already notice what's the pattern. This is just a quadratic equation. Okay, so k minus 6 and then k plus 4 equal to 0. Okay, so you have your both answers here. Your answers are k equals to 6 and also k equals to 4. Either your k equals to negative 4, negative 4. Okay, so these are your possible answers. You can just leave it like this. Okay. It looks scary, but see, it's end of the day, it's a quite simple question. Okay. Okay, let's try. Let's go even a bit harder now. Okay, now let's go for something that is more logical. Okay. It's a logic question. Oh, wait. Oh, there we go. Question 17. Okay, find the number of negative integers greater than 1000. Uh, divisible. Okay, I think I quote here. Divisible by 27. Okay, so remember when it comes to negative numbers, sometimes we like to just think 1001 is bigger than 1000, right? But then in negative, it's the opposite. Like in negative 999 is bigger than negative 1000. Sometimes we tend to forget something very simple like this. So when it says smaller, when it says greater, right, you have to go for something. The number itself will be smaller. Okay, it will be by is negative, so it is bigger. Okay, so how do we solve this question 17? Okay, okay. One way can maybe can go to it is A. Okay, A1. I think A should be actually 999. I think 999 you can actually divide by yeah, by 27. It's negative. This is 27. Okay, the largest negative number that is divisible by 27 is 27. Okay, this is the biggest number we can find. Okay, if you start from here at negative 1000, you count down, okay, negative 999, and you keep going down. I think the largest number or is actually negative 27. Okay, there's the smallest number you can imagine that. So we actually use the formula again. The L equals to A plus n minus 1 thing. So we start from there. We can actually say it is 27 negative 27 equals to negative 999 plus n minus 1 and bracket 27. So this is just maths again. It's basically maths. You can find that it is the
Why did we write negative 27?
why is it? Well, remember I mentioned just now, they asked that find the number of negative integers greater than 1000. So in this scenario, you're starting at negative 1000 and then going down until closest value lah. But remember what's the smallest negative integer? The smallest negative integer is negative 1. But they want divisible by 27. The largest number you can find that is divisible by 27 that is negative is 27 itself, right?
Okay.
So we're basically trying to find the last value here, and using that we're trying to find n. Okay, negative 999 is the first value. I think you'll get how much you get out of it. Where is my notebook? I'll just put it in my okay. Let's say we go through here. Calculator 0.99 divided by 37. Yeah, 37. So this 999, that's why we pick 999 because it's actually the smallest number, or in this case, it's the A. It's A. So 99. That's why I mentioned here is A. So we're doing like a reverse logic in this question. But usually we use it for positive numbers, right? We can also use it like this also. Sometimes it looks a bit weird, but it works. It works. Okay, that's the beauty of it. Okay, so I'm not going to open this. It takes a lot of time to all the kindle. Just know that when it's negative 27, okay, that's the largest value we can find. So that's the last value equals to negative 999 plus n minus 1 bracket 27. That's the d, right? Remember d. Okay, so it's changed by d. So answer you'll get is n equals to 37. Okay. You can also say you can just also say negative 999, then divide by 27. Also can, you can just get 37, but this is more accepted. Why? Because we're using the terms that they provide. We're approaching this mathematically. This is Puro's logic. Okay, just say equals to n. Because I know that this is the biggest value, right? If I divide this by 27, that's how many 27 it has. Okay, that's all the 27 from negative 1000 until negative 1. Okay, I can just divide by this by 27, I can find n. This is using applying the mathematical method. Okay, so that's one question.
Divide by 27 means not geometric.
No, okay, for this one, what we're actually doing here is, okay, what, yeah, okay, this one is actually uses logic here like this. Okay, when I see that I have a 4 plus 4 plus 4, yeah, we can write it as 3 over 4 also, right? We can write 3 over 4, we can write it as 12. So in this case, okay, it's actually very simple logic here is that when I say that is a negative 999 is divisible by 27, okay, divisible by 27. That means that there's so many 27, okay, 27 plus 27 plus 27 plus 27. So many of that until it will all equal to 37 divided by 27, I think, right? Yeah. So I can also write this as 990. Do you understand what I'm trying to say? So when I divide this by 27, I'm just finding out how many 27 there is. There's 37 27s in 999. So that is just the straightforward. This is not about geometric. It's the arithmetic. Yeah?
Okay.
Okay. Okay, so we have done until question 17. Okay, let's go for a bit of a harder one. Okay, where do we go at this one? Okay, let's go with one of the harder question 19. I think question 19 is a nice number. Nice question. It's quite tricky also. Why I say quite tricky? It has a lot of words. But that doesn't mean anything. Okay, let's try question 19. Okay, arithmetic progression has the first term a and common difference 8. Okay, always dissect the question. A is a, b equals to 8. Okay, sum of the first n terms of the progression is 1000. Okay, so we can say the sum of the n, okay, 1000 equals to, okay, sum of the n terms. Okay, so this n lah. Okay, n, okay, I just put AP here equals to 1000. Okay, so if you have to remember, okay, so you have to just this is the logic. So okay, it's an arithmetic and it's an n. Okay, there's something, it has to do something with fractions. Why I say something with fraction? If it's a whole number, okay, let's just use a logic here. It's a whole number. Okay, that means example I say as y equals to mx. Okay, so if y equals to mx, it will always be like this, right? A straight line. So when I say it's a sum, okay, when I say it's a sum, you also actually think of it as a function, like integrating a function. Okay, you're integrating a function where you take the value over here and you below the graph. Okay, when what I mean by that, you take all the values of here. When x equals to 1, how much is this to the third, then you'll find how much. Okay, let's say it's 3, or and then one upper x equals 2, the other equals to 6, whatever. Okay. When you add all of these up, when the function keeps going like this, you usually get the sum will be equals to infinity. Okay, will always be equal to infinity. Why? Because there's n term what you just keep going up, doesn't stop. So when it comes to something that's a limit like this, n terms it's 1000. So it doesn't go more than 1000. It's usually a reciprocal. Okay. Usually a reciprocal. Why is it usually reciprocal? Okay. Try to think of how a reciprocal looks like. Reciprocal looks like something like this, right? It looks something like this. So when it goes here, it keeps getting smaller. Okay, and but it never touches that line, right? So when we take this area, it usually a fixed amount. It doesn't really stop. Okay. After a certain point, it's like what? The difference is like 0.00000001, something like that. Okay, let's say x equals to 10 to the power of 8, and then x equals to 10 to the power of 10. 10 to the power of 8, 10 to the power of 10 is very big difference. So even in this big difference, maybe the difference in here is like 0.0000, maybe it's like 0.05, something like this. Very small, very small. So when it comes to that, you can just sum it up to these values. So that's what we're doing here also. And remember, as you can see, if you look at the equation, what you get is also a reciprocal. 100 over n minus 4 n minus 1. Okay, why did I explain all of this? Okay, it's just to give you imagination. You always you need some imagination when it comes to arithmetic and for geometrics. Okay, then the question says given that n term is less than 4000. Okay, so n term is less than 4000. So x, the final x equals to less than 1000. Okay, let me check in some water. Okay, and then show that n squared minus and hence find the largest possible value of n. Okay, so we want to find the largest possible value of n. That is still gives the sum into 1000 and also works in this formula will end up giving us this. So we're actually tackling two problems. We're gonna use the sum, we're gonna use the formula, and using the sum and formula, we're gonna get this equation. Okay, that's what we're doing. Okay, so I have to remember what are we trying to do. Okay, so where do we start? Okay, let's just take the data we just got. Sn equals to 1000 and b equals to 8. Okay, so two things, right? So remember the sum formula for arithmetic is n over 2. I'm not going to the formula because these are all given. These are all given in your book. So that's why I'm skipping to the formulas. It's not really necessary to go through here and dissect the formula. Okay. N minus 1 b equals to 1000. Okay, so here we can just move everything here, theta, you'll get 2a plus n minus 1, 8 equals to 2000 over n. And then more theta, you'll actually get a equals to 1000 over n minus 4 n minus 1. Okay, you should get this, and this is exactly as the questions in the equation, you actually get it back. Okay, since there's a typo in the question, this shouldn't be 100, this should be actually 1000. Okay, this is a typo in the question. Should be 1000. Okay, never mind. Right, okay, so that's one thing done. Okay, so how do we translate this into the second part? Okay, like I mentioned, there's two things we have to do. Okay, from this, we can continue further. So we know that what is Tn? Tn, nth term equals to a plus n minus 1 d. Okay, so we know what is a. We know that a is this n minus 1 plus n minus 1 d. So we can shift plus both of these together. Excuse me. We will get 1000 over n my plus 4 and minus 4. We will get this. We will get this thing. And what do we do here? Okay, so this is where that less than 4000 comes from. Okay, so we have to say that this thing is okay, I think there's another type here
Minus
also.
4n plus 4.
4n plus 4 minus 4n plus 4. Oh, sure. This is a d, right? This d will give me 8. So it's 8 n minus 1 minus 4 n minus 1. So that's 8 n minus 1 minus 4 n minus 1. I'll get 4 n minus 1, which is 4n minus 4. Correct. What? Did I miss anything?
I don't understand.
What do you not understand?
8n minus 1 minus 4n minus 1.
Ah, okay. So what we did here, we use the sum formula to find a. Okay, I told you this just now, I mentioned this now in the question. We are doing two things. One, we are gonna handle the sum progression to equals 1000, and then using that, we're gonna tackle a. We're gonna find a. So how are we gonna find a is first we find by using the sum we have to find a. Okay, so I say that Sn equals 1000 and d equals to 8. Then using the formula for sum of arithmetic equation, we get that it's equal to 1000. Then I pinda everything together. Okay, I'll get that a equals to 1000 over n plus inside my minus 4n 4n minus 1 dapat. And then using that, I'm gonna go to arithmetic term. The term equals to a plus n minus 1 d. So in that, I already know what is a. I'm putting back a in. So inside here is negative 4 n minus 1. Then plus this thing n minus 1 d. I know that d is equals to 8. Or they already mentioned in the question, d equals to 8. So 8 n minus 1 minus 4 n minus 1. And then continue now. You get 4 n minus 4. Okay?
Can.
Alright. So from this, actually, I think there's a problem in the question. It cannot be 4000. It will give you a negative number. Shouldn't be. I think it should be 400, and the 10 from here went to here. It's a typo. It's a typo. Sorry. So maybe you couldn't solve the question if you didn't change this. Okay, I think it should be less than 1000. It should be something like this: 1000 over n plus 4n minus 4 is less than 400. So it should be 1000 over n plus 4n minus 404 less than 0. Okay. Then you can use the quadratic equation. Okay, you can square all of this, like you square all of this first. So you get as 1000 plus 4n squared minus 404n. And then you can, I think you can simplify, divide everything by 4. Then that's be 250 plus 4 plus n squared minus 101 and this is 0. So you can get this. Then using this to use the quadratic equation, I think you'll get is x, or not x, n. Okay, n1 equals to, it's a long number, but I think in the calculator you'll get this one to the 4 significant figures. 98.46 and also 2.54. I tried just now using 4,000. I didn't get around a complex number, so cannot lang. Okay, so what does this mean? Okay, so this, remember, this is a range. This is a range. So this is the range of values that n can exist in. Okay, this is the end of values that n can exist in. Okay, so that means that when I say n squared minus 101 n plus 250, this thing is less than 0. That means that if the values are in between 2.5, okay, n is between 2.5 and 98.46. So the largest integer, the largest value, because they want the largest possible value of n, right? That's the question. Yeah, that's the question. Wait, that's the question. Largest possible value of n. It should be 98. So I will say that n equals to 98. That's the largest possible answer we can have. Because we cannot go to 99 because the value doesn't exist in 99. So it has to be 98. Okay, so that's been an hour since we started class. We how many questions have we done? 1, 2, 3, 4, 5, 6, 7. Oh, see, I cannot publish. I can publish 1 point. Okay, now it's okay. Maybe I can do extra class during this. We can just do the extra questions here. But for today, we'll maybe try to finish just 1.1 lah. Okay, just try to finish 1.1. Okay, no issue. Okay, let's take a 10 minute break. I know this chapter memang sakit kepala. I think you also send me something. Are they working? Yeah, it's also working now. A equals to n. But it got plus. Okay, correct. Negative and plus. Why did you get negative and plus? Oh, you left it here. Oh, okay, I understand what. Yeah, here you're supposed to get negative and plus. Okay, here. This one you get negative and plus. Okay, here you get. After that, you when you plus this thing, the sign will turn left. Okay, so that's
Okay.
for us. Okay, but so far your working is actually correct. No problem. It's just that you forgot to input this into the second part. No worries. Okay, let's take a 10-minute break. I know this chapter memang is something that hurts our head sometimes because it's like, oh, do I solve it this way or solve it that way? But no worries. You do enough of the practice, you can get it. Okay, but take a break first. Go take a break first. We'll come back
Can.
around 9:50. Then we'll continue the class. Yeah. Okay.
Okay. Bye.
All right. All right. Bye bye. See you. Okay. So again, so it's now we finished most of, I think, arithmetic now.
Mm.
Let's start with geometry. Okay. So same here. Find the first terms and common ratio of the geometric sequence a n equals to 5, 3, and okay. As for first terms like this, always give 4 terms. Why 4 terms? usually it's like A1, A2, A3. Then you do the dot 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 and check. And you can give also A4 lah. Okay, no problem. So but 4 is enough. Okay, 4 is enough. Okay. So I would say how much is A1? Okay, let's try see what's A1. Okay, A1 equals to 5, 3, and 5, 3, 1. That's 50. A2, okay, that's 9. 9 times 5 is 45. Okay, A3 is 27. So the now mistake 27 times by 5 is 135. Oh, okay, you've already done it. Okay, that's good. A1, A2, okay, A1, A2, yeah, A1, A2, right. Okay, then R is
But if I don't find A3, is it okay?
Not really a big issue, but usually we ask for first terms, give at least 3. Give at least 3, but I should actually at least 4, but give until 3. Okay? Yeah, because think of you, it's a very simple question. If it's like this and you come out your STPM, oh, so nice. If you give, I give 10 also, I no problem. You can ask me
Mm.
something like this. Yeah, yeah. You can. Okay, for you can. You're not supposed to do it like. Uh, not supposed to do it like that. Why is it not supposed to do it like that? You're supposed to start here. A n minus 1, and then after that, you're supposed to do it like this: 5, 3, and then you say um 5, 3, n minus 1. Okay. I know it looks silly. Why can I not do this? But this is a form 4, form 5 method, and you do this 45 minus 15. Okay, so for form 6, I better you try and do this now. So you'll be left with 3n over 3n times by 3n minus 1. So cut this, you have 1 over 3n minus 1, which is less equal to 3. Okay. This is how you're supposed to answer this
Times
question. Okay.
3.
Now you still get 3. You can put 45 or 15, not an issue. But usually this is how you answer this question. Okay, you have to break all of this down because it's always gonna sometimes be this simple. So it's always better to put n and n minus 1. Okay. Not only for geometric, also for arithmetic. So okay. Let's go to question 23. Okay, let's read the question first.
I sent my working. Can you check?
Oh, okay, for 23. Okay, A equals to 2, 2, 5, 6, 2, 5, 6, 3, I equals to 2, A equals to R equals to 2. R should be negative 2, not 2. R should be negative 2, not 2. Yeah, something bothering, something is missing here. What is missing? 32, 2, 5, 6, 5 minus 1, that's 4. 8 minus 1, that's 7.
Yeah, negative.
Negative. Oh yeah, negative 2, 5, 6. You've hilang already. Hilang 32 over 2, 5, 6. Yeah, okay. So A5 equals to 32. A8 equals to 25, negative 256. So I want to say AR7 over AR4 equals to negative 256 over 32. So it's R3 equals to negative 8. Yeah, should get negative 8. Then R equals to negative 2. Then A negative 2, 4, 32, and A will equal to, yeah, it should be negative 2. Still, but no problem. A small error, but still that will cost you marks. But yeah, I hope questions like this, when you make error like this, right? It's actually very simple to correct. If you just butcher the question one time, you'll usually be able to correct this type of issue. Okay, so I hope you can correct this issue later when you are doing the exam. Okay, now let's see question number 24. Insert three geometric means between 6 and 16 and 625. So they're saying that, okay, okay, let's say whatever it is, okay, let's make it A16, doesn't matter here. Then you have P2, P3, P4, then P5. So P5 is 625. Then don't know, don't know, don't know. So I have to make it a geometry. So how do we do this?
When I should use T1, T2, T3, when I should use UN, U1. Same?
Doesn't matter, just terms, just term. Doesn't matter. The character doesn't matter. Can use U, can use T, as long as it's something
A
that's
also can.
commonly used. Yeah, A if you want to use for first. A is usually for the first
A,
term, so don't. It might confuse if you use A for something else.
but before this, we also use A1, A2, A3, A4, right?
Have we? Have I used? Oh yeah, have.
We, uh,
Hmm. Can also, can also. As long as the person understands, I think it shouldn't be an issue. Okay.
okay.
Okay. As long as the person understands, no issue. Just don't make sure it's a commonly used term. Don't put Z X Y in this section of your this question 2, right? This is sequence and series, so this question 2. So don't just put X, Y, and Z. That's okay. Back to question. Okay, so this A 4 equals to 6 to 5. Okay, so that's you know A is 16, so that's 16. 4 equals to 6 to 5. 4 equals to, I think it's 6 to 5 over 16. Okay, this thing is a trick actually. You can do something. 4 actually equals to 5 over 2 power 4. So this I can do straightforward like this. It's just a trick. If you notice this pattern, nice. If you don't notice, it's completely fine. Okay, it's completely fine because at the end of the day, if you put in calculator, you still get same answer. But don't forget the 5 plus minus should be plus minus. Okay, so r equals to plus minus 5 over 2. So when you get this, you can just input back here. So it'll be 16. What is this? 16. 5 over 2. Upper, this should be 1. 16. 5 over 2. 2. 16. 5 over 2. 3. Okay, later you can just expand now. If you want to expand, you can expand, but no, it's better to expand. and just put the values. Just say T2, T3, and T4 equals to dot, 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 dot. Okay. Okay, let's go to the next question. Skipping question 26, it's quite similar to question 20. I mean, I'm skipping question 25. Quite similar to question 26. Okay, so let's go question 26. Okay, if the first and sixth terms of a geometric series are 1 to 5 and 1 over 25, find the nth term, 10th term. Okay, so we know that
Just now the answer 5/2.
5 over 2 is r, yeah. R is plus minus 5 over 2.
Okay, fine.
Alright. It can be negative also because we don't know what's going on here. So even if it's negative 5 over 2, when it comes to T5, it will make sense. Because T5 is power 4, right? So it's negative also, you still get the value. Okay.
Okay.
So here, let's go back to here. So how do we solve it? Okay, first and sixth term. So n equals to
Can scroll up for a while again. I want to ask something.
scroll up here.
Sorry. No, some more down. The mean geometric
Okay, sure.
5/2.
No question?
Okay.
Or you wanted to?
I already know.
Okay, sure. Okay, then you have A equals to 1, 2, 5. Okay, and then finally Tn. Okay, I don't know what is n, but I know that Tn equals to 1 over 25. Oh wait, T6, right? T6 equals 1 over 25. Okay, for this one, how do we solve it? Okay, so I can see that 1 over 25 equals to 1 to 5 half over 5. Then r over 5 equals to 1 over theta, 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 actually 3, 1, 2, 5. Then power by like per 1 over, just push the power to the other side, you'll get r equals to 5, yeah, 1 over 5. Okay, 1 over 5. So what can we do with 1 over 5? Just copy the question. T10 equals to A 9. So that equals to 1 to 5. 1 over 5 over 9. You'll get 1 over 1, 5, 6, 2, 5. Something like this. Okay, dapat. Okay, next question. Okay, this one looks a bit complex, but actually no, actually also really straightforward. It's actually one of the most straightforward questions here. Okay, so the C here is compute the sum of okay. To me it looks like the series is geometric. Seems like the series is geometric to me, with a common ratio of negative x. So I can just say that is so this is actually guessing lah. Okay, why I say guessing? Okay, A is like positive, negative, positive, negative, positive, negative, and every time it's positive, negative, it's multiplied by x. Okay, that positive and negative x. Then times again by negative x, then times again by negative x, and times again by negative x, times again by negative x. So I feel like R is negative x. Just testing R negative x. Okay, I'm just testing it out. And I see it changes 6 times. Okay, 1, 2, 3, 4, 5, 6 times. 1, 2, 3, 4, 5, 6, 6 times. So I want to say S6 equals to, Okay, I know A is 1 because it changes from here. 1, right? So 1 bracket 1 minus negative x. This or 6. Oh, 6 outside, right? Over 1 minus. Okay, I should get 1 minus x 6 over 1 plus x. Looks a bit okay, and I think that's about it. Question looks hard, but that's because you just haven't tried questions like this before. But it's quite straightforward, right? Just you have 6 terms here, plus 6, and then you have this change. What is the change? The change is by negative x. So quite straightforward. Okay, so let's try the next question. Skipping question 28. Trying question 29. Okay, this one will start to be a bit harder now. This is starts already on your investment interest questions. I think your year, I get these questions can come up for your section B. Some
Mm.
sequence and series, they're gonna ask questions like this because you guys are KSSM. On your syllabus, this is highly requested because okay, this is a bit off topic, but actually the reason why
But
we are
even for
changing.
our SPM,
Mhm.
we had the similar one for what sequence and series chapter.
Yeah, that's why I was mentioning here. Yours, we are also targeting that this question comes out for your SCPM also because the reason why we have KSSM, your syllabus, is because of the industrial revolution, fourth industrial revolution in Malaysia, not just Malaysia, all over the world. Okay, so in this fourth industrial revolution, what we wanted is more application of hands-on. Okay, we noticed the government noticed that a lot of students were just they tak memahami soalan, tak memahami what is going on. They don't understand what is going on, but they just hafal. Everything is memorized, and they just vomit back whatever they answer in the paper. So that's why for your year for SPM, more of your marks was given towards projects. Okay, some people might say that is easier, but actually the thing why it's easy is because the teachers are helping you guys. But if let's say that your project was conducted outside, it'll be very hard compared to an exam because exams are proctored, exams are all the same. Okay, but when it comes to
Mm.
projects, it's actually quite harder. It's only easy because that the teacher itself is the one who is grading your projects or your experiments. I would say what the goal of this KSSM is actually is good. The goal is good, okay, because I know that even my batch and my seniors also, a lot of them are book smart. But when it comes to applications, even me also included, when it comes to application, I might start to stumble a bit. Okay, it's a good implementation, but the problem with this thing is they don't
Mhm.
test the students in. So, okay, all of that coming back to here is one thing that they notice is that the STEM students they lack a lot of other skills. So STEM students only know STEM, so they don't know anything about investment. So that's why they added these things in your syllabus also. Okay. Okay, so okay, that's enough of me just going off tangent. Okay, let's try this question. Okay. Wei Peng, Wai Peng, sorry, receives 300 ringgit for her 18th birthday and opens a bank account that provides 1% compound interest per annum. Okay, let's move that. So it's 4%. 4% compound interest per annum. Assuming she makes no withdrawal, no any further deposits, how much money will she have on her 21st birthday? So that's 3 years. Okay, 3 years. 18 until 21, that's 3 years. If White Pink receives 300 on every birthday, following her 18th birthday, how much will she have by her 25th birthday? Okay. So one question is geometry, one question is arithmetic. So let's see how this goes. Okay, this can be okay for the first part is actually still geometric. Okay, so your A equals to 300 and your R equals to 1.04. Okay, then you can just do this U4 equals to AR3. You can just do that. So it's 300 times by 10.4 power 3. Okay, you can get the answer 337.46. Okay, she will have a roughly amount of 337.46 Shujilla on her 21st birthday. Okay, then after that. Then after 1 year, the balance will be okay. So this one you have to let's list it out. So 1 year. So let's say U2. Okay, you say
Can
U1.
we continue? Can we continue like this, or do for 1 year first and then use the
Ah,
remaining
can
again?
also you can use that also, but it's a lot of work lah. I think if it's because it says a simple compound interest, you just do it straightforward. But I'm also going to do that now for the thing you mentioned just now. I'm gonna do it uh now. I'm gonna try that method for B.
So we don't have to use the compound interest formula.
No, I don't think it's necessary. You can just use the geometric one. Geometry should give you the answer also. Okay. All right. Okay. So U3. Okay. So U2. Okay. The first year after the first year. So that'll be 300 plus 1.04 times by 300. Okay. So that will give me jump. Okay. Yeah. Then I will have how about U3? U3 will be 300 plus 1.04 U. Okay, then I think U4 will be 300 plus 1 over 0 for U3. Okay, add. Okay, so by her 25th birthday, that means it's
1.04 U2 or 300 plus U2.
300 plus 1.04 U2. Because U2 is already this one, right? So we're just subbing inside. And then this whole thing sub inside. Okay. So from 18th to 25th, how many years is that? That is 7 years, right? So 7 years. So we have to find until U7. U7 equals to 300 plus 1.04. Okay, let me double out. U6. Okay, so how can we answer this? Okay, this one you can use a sum formula. Okay, if you remember what's the sum formula, it's like this, right? Okay. So U7, I can also write it like this, equals to 300 bracket. Or maybe I can expand. Or maybe if I expand, it'll be nicer to show you. Okay, it's okay. We have time. We have time. Okay, so, not really that bad. I have time to explain. Okay. So I can see that again U1 equals to 300. U2 equals to 300 plus 1.04 300. Then U3 equals to 300 plus 1.04 U2, okay, which is basically again 300 plus 1.04 bracket 300 plus 1.04 300. Okay, then U4 equals to 300 plus bracket 300 plus 100 for bracket again 300 plus 1.04 300. Okay, and so on and so forth. So when you have this reoccurring pattern, okay, I think you can just sum up this pattern into something that's easier. The summation formula, if you remember that, okay. So the summation formula will look something like this. So by the point that it equals to U7, you can say that A is 300, and then I say 1 minus 1.04 the power of 6, and then 1 minus 1.04. I think this formula is given already in your exam paper, right? I don't have to explain this formula, right? Okay, okay, this one given in your formula paper. Okay, so that's
Okay.
300, okay, over 6.633. So how much is this? Can you type on your calculator? I didn't
But
write
why we times 1 2 times?
Oh, actually, why we times 1, 2. Okay, this is 1 times 1 minus. Okay, we're finding the difference here. And
Huh?
then from the difference, we times by 1.
Why?
Okay, what is the formula for this? Do you remember?
A 1 minus r to the power of n.
A 1 minus r to the power of over 1 minus r,
Minus
right?
r. Hmm.
This one is more than this one. Oh, wait. Oh, it's on. Yeah, yeah, yeah. Sorry. I was thinking of something else. Okay. Okay, so it just be 1 minus 1.04 to the power of 6. Okay, dapat tak? I think you will get, okay, I just think the calculator out. I think you'll get a 1989.90. Is this what you will get?
Correct.
Okay, so the first question is, okay, just to recap, the first question basically says that if she only has one time, she only masuk dapat duit one time. Okay, but after that, what they're trying to say is, what if she must dapat duit 300, and every time she dapat 300, she put all of the money also inside. So that's what we're doing actually now. One part is just one, she gets money once. So you see, in just 7 years, she got like 2,000 already. You can see it's not much, but if you think about it, just 300 once a year. 300 once a year is not much, not big money. But then when you compound everything, it suddenly becomes let's do some maths, right? Okay, so that's 300 times by 7. How much is this? This is
2,100. 2,100.
oh wait, 6 years, 6 years, 6 years. Should be 6 years. The term should be minus 1. Okay, should be 6 years. So should be get 1,800 lah.
800.
So
Hmm.
if she just left the money in her account, she'll just have 1,800. But if she, because she put it in her investment, so that's 1989 minus 1800. She's getting roughly what 189, 189 ringgit. Okay, for small value, okay, maybe 300 ringgit tak perasan. But if you put like maybe 2,000, 3,000, 4,000, this value also increases by that much. What? So maybe this value will be a difference of 1,000 ringgit in 5 years, 1,000, 2,000 ringgit in 5 years. Okay. So investing is good, but make sure you don't invest. This is just a life lesson. Investing is good. Okay, investing is good, but the thing about investment is make sure you have enough money for now. Okay, don't invest everything later. Sekarang makan Maggi. Don't like that. So make sure you have enough for now, and the extra you invest. This is a life lesson. Okay, so okay, question 31. Question 31 is actually quite straightforward. Sometimes macam susah kan, but actually quite straightforward. Okay, a ball is dropped from a height of 10 meters to the ground. It always rebounds two-thirds of the distance that it drops. Okay, so it's like this physics already, right? So it's like it drops 1 meter, then comes back 2.5 meters, two-third meter. So how far up and down? So the ball has to go down and then two-third square and up again, up down again, up again, down again, up again, down again. Okay, will the ball have to travel when it hits the ground for the fifth time? So I find the fifth lah. And they want to find how far up and down. So they want to find the displacement. Okay, so we want to find displacement. I think you can just answer this very straightforward. Displacement means total displacement is Sn A1 over 1 minus Rn over 1 minus R. You know that the first time is 10 meters, right? Yeah, 10 meters. So the first time 10 meters, so that's 10. 1 minus 2 over 3. So 2 over 3. 5 minus 1 minus 2 over 3. Okay, so how much is this? This is a total of 26 4 over 81 meters. This is how much it travels now. Okay, so this is only the total amount, but you have to remember the first 10 meters is not included. They only ask for rebound. Okay, they only ask for the travel when it hits the ground. Okay, so you have to minus the 10. So the answer is 4 over 81 minus 10. So you'll get 16 4 over 81 meters.
But better to give in decimal or fraction.
Up to you. When I was calculating, the answer was in fraction, so I just left it as a fraction. But up to you, no problem. But if you want to give it as a decimal, make sure it's at least 3 significant figures. But if it's okay, if the answer is a rational fraction, meaning that you can explain it in a fraction easily, use fraction. But if the answer it doesn't have, it's very messy, just use decimal, no problem. But better to use something that can hold the value, like example decimal. If you square decimal, the change will be very big. The changes will be very rapid. So it's not good when you're doing geometric progression. But if you square a fraction, the fraction will still remain a fraction. So not really a problem. You will not miss any value. You will not lose any accuracy. So if you can, try to leave it as a fraction. Okay. So that's that. Okay, so total distance the ball has traveled. Okay, so we are only this part. We are only calculating. What is this? This is the rebound. Okay, this is the rebound. The every time it goes up, we're actually calculating just every time it goes up. So this is only half of the calculation. One, the total distance means, if I'm not mistaken, you have to plus everything. So that will be 26. 4 over 8, 4 over 81, then plus again 16, 4 over 81. So get 40, 52. Oh, sorry, 42, yeah, 42, 8 over 81. Yep, so this is the total distance traveled in meters. Okay, why again? So we have to remember that the distance ball drop. So every time it drop. Okay, that one we are calculating by 2 over 3. Okay. Okay, that's 2 over 3. So atas pun 2 over 3, bawah pun 2 over 3. So that we're taking that value. we're trying to find this 26 4 over 81. Okay, we found out already. And then we have to also remember I have to minus 10 to get the first part. Only the rebound. Only the rebound. So we don't take this first part. Okay, we only take this one only. And then this one we only accounting for one side. We're not doing it both sides. We are only counting for one side because this 2 over 3, this sum only gives us for one side. But remember the ball card is actually going down and then coming. Okay. So if let's say first time it goes it's like 2 over 3, right? So it's like 2 over 3. When it goes down also it's also going back 2 over 3 times. Okay, 2 over 3. So that's why we're doing it 2 times. And then we on the other one we also add the 10. Adding the 10. Okay, why we add the 10? That's because the question wants the total distance traveled also. That's why we're adding the 10. That's why it's 26 4 over 81 plus 16 4 over 81. Okay, so that's our question. Okay, last question for the day. I think this one will be enough for us to end the class session. Okay, so the sum. Okay, let's try to do this question. The sum of the first two terms of a geometric series is 7. So that's t1 plus t2 equals to 7. And the sum of the next two terms is 7 over plus 4. So that's t3 plus t4 equals to 7 over 4. Okay. Find the common ratio angle C. So how can we solve this question? Okay. How about let's try it like this. Okay. S2 equals to 7. And I know that A r squared minus 1 over r minus 1 equals to 7. Okay. And I also know that S4 minus S2 equals to 7 over 4. These are my two equations, 1 and 2. So what can I do with this? Okay, what can I do with this is that I can actually change this around. So let's say S4 equals to S2 plus 7 over 4. S4 and 4, 28. 28 is it 35? So that's 35 over 4. So S4 equals to 35 over 4. And I can actually say that S4 equals to A or AR4 minus 1 over R minus 1, right? And this equals to 35 over 4, right? From this equation, I can have two things ready. I have this part. S4 equals to this much, and then also I have this also. Okay, so what can I do with this? Let me see. Okay, you can make it in terms of A. I think that's the easiest way to answer this question. So if you make it in terms of A, that means that A equals to 7 R minus 1 over, what is that again? R square. A R square minus 1. So you have another one, A equals to 7 over 35 over 4 R minus 1 R power 4 minus 1. Okay, so since these both equal to each other, so I say 37 R square minus 1 equals to 35 over 4 1 over R power 4 minus 1. Okay, why I minus this side? Because both are the same, right? So I just cancel these two out. Okay, so 7 and 35, I can also make it easy also. I can take away. So that's a 1 over R square minus 1 equals to 7. Oh, sorry. 5. 5 over 4 half 4 minus 1. Okay, this one also I can actually simplify. I can make it easier because I know that r square minus 4 minus 1 equals to 5 over 4 over. Okay, this one r squared plus
The
5.
35 over 4 is the sum of 4 terms.
Yep,
The 7,
the 7 is the sum of the two terms.
2 terms. Okay.
Okay, then I can cancel. Then I'll get r squared plus 1 equals to 5 over 4 plus here. Then I'll get is the r equals to r squared equals to 9 over 4. And then finally answer is square root of this stuff, plus minus
3 over 2.
I think that's the answer. Wait, let me see if I miss anything. 35 divided by 7 divided by 7, so it's 5 over 4, 5 over 4. Okay, then hidang r4 r square hidang di sana plus. Oh wait, this should be plus. Sorry, should be plus, not minus. It's plus, right? So
So 1 over 4 plus minus 1 over 2.
so it's plus minus 1 over. Okay.
Okay.
Okay, so I actually plan to finish more questions today. There's a few more, I think, on the whiteboard. I mean, not on the whiteboard.
Google Classroom.
Google Classroom. Oh wait, I thought 32 only. I seen that banyak lagi. Okay, there's a bit more. I didn't post on. I think not on the Google Classroom. Okay, for this one, I'll go check where it went. Because this one's a bit harder. Okay, so I'll post this one later, or maybe this week. This week, I'm not sure about my calendar. Maybe I can have an extra class either on Tuesday, maybe, or on Wednesday. I see lah how. Okay, one of these days, maybe pukul
Tuesday or
macam
Wednesday.
Tuesday or Wednesday around 6 until 7, just for a while only. Okay, we just discuss a few more questions. Okay. Later I'll post on tomorrow afternoon. I'll post if I can make a schedule at that time. If I have class, then I'm sorry, but I think I shouldn't have any classes.
The extra class Wednesday can?
Wednesday. Okay, I'll check this because I have a few things going on this week until I won't be free until January actually, because I have all my exams are coming up this week, so it's a bit packed. I'll try to make some time also like 1 hour, right? I think I can find 1 hour. But you guys are holiday, right? So maybe if it's a bit late also, I think it's okay. If it's a bit late, I hope it's still okay lah. Maybe like 10 to 11, something like that. Because sometimes I come back after classes also after 10 to 11 lah. So I have to rush back here also. Let's see lah. I'll tell you guys on Monday night. Okay.
Okay.
Okay, I think
Thank
that's the
you.
end of class.
Bye.
Okay, bye. Have a good rest. Hopefully see you by this week again. All right.
Okay.
All right. Have a nice day.